Today we're going to look at inverse sine, cosine, and tangent functions. And we know that from previous discussion, inverses of functions basically involve switching the x and the y and solving for y. We also know that these functions are symmetric about the line y equals x. So what I've done is I've gone through the progression of looking at the inverse. If you have y equals sine of x, then that's x equals sine of y when we try to find the inverse. And then if you're going to solve for y, you have to take the inverse sine of x to get y. We did that back in geometry, so you've seen that before, and you probably did that in algebra 2 a little bit. So if you'll take a look at the sine graph right here, this is what we're used to seeing, going through 0, going to a high point, back to 0, and down. If I were to reflect that over the line y equals x, I get a graph that looks like this blue one here. The only problem is that that graph, in this case, is not a function. If we were to find the domain and range of just regular sine, we know this is all real numbers. Right? And then our range would be between 1 and -1. Now, in looking at this graph, if we want just a portion that is a function, anything that overlaps in the blue is not a function, so I can't do that. So what I'm going to do is I'm basically going to pull out a piece of that graph that never overlaps. So that's this piece right here. And over to the right, I have a graph of the actual inverse sine, or we call it arc sine in this case. Same thing. And if I look at the domain of this, you'll notice the domain goes from -1 to 1. And the range in this case is going to go from -pi/2 to pi/2. You'll notice that the range and the domain basically flip. In this case, we can't really count a domain of all real numbers, since the all real numbers doesn't make this a function. But if I were to just use this green part here, you would note that this goes as high as an equivalent of pi/2 down to -pi/2. So the domain and range really switch, which makes sense because we're switching the x and the y's. Likewise for cosine, I switch the x and the y, solve for y by taking the inverse cosine. We've got a cosine graph starting at 1, going down, coming back up just like we're used to. If I reflect it over the line y equals x, we notice we don't get a function. So we're going to pull out the part that is a function in this case, and that would be this portion here, where we come down and go to this degree here. Looking at the domain of the regular cosine function, we know the domain of the regular cosine function is all reals, but the range is going to fluctuate between -1 and 1. Likewise, you'll notice that the inverse cosine graph has a domain of -1 to 1, and the range is going to fluctuate from 0 to pi. Tangent's a whole different story. You'll notice tangent repeats itself over and over again. The domain of tangent, we know, well, we can do this a couple of different ways. I'm going to go to the domain, take this piece of it right here. All right, is basically x is not equal to any multiple of pi/2. and 180 degrees thereafter. And then the range is all reals. You look at the inverse graph after I reflect this over the line y equals x. That would be several of these stacked on top of each other. Everything stacked on top of each other makes it not a function, so we take one piece of it. The domain is all reals. And the range, you'll notice, fluctuates between negative pi over 2 and pi over 2, which is indicated here. So once again, the x's and the y's are switched as we'd expect. So in taking a look at the cotangent function, you'll see that we have roughly 4 periods of cotangent represented here, and it decreases as cotangent should. If we switch the x and the y and solve for y, here's our inverse cotangent graph, and you'll see that it really does decrease as we go through the values of theta. We go from 8 to negative 8 as we grow from 0 to theta. So this is defined from 0 to pi, because if we were to graph another period of this somewhere along here, it would stack on top of each other and not pass a vertical line test. So again, this is defined from theta going from 0 to pi. Okay, or its inverse is defined, theta to 0 to pi. Now, as a cheat sheet, what I usually do is I draw a couple of pictures. I have 3 functions whose inverse can only be derived between negative pi over 2 and pi over 2. And I have 3 other functions whose inverses can only be stated between 0 and pi. So once again, sine, cosecant, tangent can only exist, their inverses that is, between pi over 2 and negative pi over 2. And cosine, secant, and cotangent, their inverses, can only be expressed in terms of values between 0 and pi. Now, we're not going to necessarily graph a whole bunch of these, but what we are going to do is we're going to use inverse notation to find values. So when we're asked to find the inverse sine of root 3 over 2, it's basically asking what angle measure gives you the following values. So what we're going to do next is we're going to solve some actual inverses, not necessarily graph them, but solve equations or expressions in inverse notation. When I'm asked to find the value or the exact value of the inverse sine of root 3 over 2, I'm really asked what angle measure gives the following values. So we're looking for theta values, typically in radians. Now the type of answers we're going to give for sine are between negative pi over 2 and pi over 2, and this goes for cosecant as well. For tangent and cotangent for that matter, negative pi over 2 and pi over 2. And we're going to give the values cosine between 0 and pi. So in this case, I want to know where on the unit circle do I get a y value of root 3 over 2. And I'm only going to answer in this quadrant, first quadrant, or fourth quadrant. So since this is positive, I have my y value root 3 over 2, and I know that's equal to pi over 3. So that's my only solution. For tangent, having a value of negative 1, I want to answer once again in my first or fourth quadrant. And when I name my fourth quadrant, it's going to be as a negative degree measure of negative 1. Well, that's exactly where it would have to be in this fourth quadrant. And I know that's at the pi over 4 value. So negative pi over 4 is my solution here. Where do I find a cosine of 0? And I'm looking for that value in the uppermost quadrant, because that's between 0 and pi. I know my x value is 0 at pi over 2. So once again, it's kind of going backwards. We're given the x or y value, or a ratio of x and y, and asked to find the angle that that happens at. Let's do a couple more. Now we're going to take and look at compositions of functions. In other words, functions within functions. And we're going to have to do this without a calculator. Now, this problem asked me to find the y value at negative pi over 13, and I have no idea where that is, but I know negative pi over 13 is probably somewhere over here, and I'm asked to find the y value. Well, once I find the y value, now I'm asked to find out what angle gives me the following y value in that fourth quadrant, or between pi over 2 and negative pi over 2. Well, I can basically state, since I got the y value from the initial degree measure, I can state that the inverse is that same measure. So I get the y value and say, where'd that y value come from? Well, it came from that original angle. It's not necessarily rhetorical, but it is a pretty straightforward problem. If I want a tangent value of 6 pi over 7, again, I have no idea where that is, but I know 6 pi over 7 is somewhere over in the fourth quadrant. Now, here's the deal, and this is why I say the previous question wasn't rhetorical. The answers we're going to give for tangent are between negative pi over 2 for theta and positive pi over 2. And we want to know what angle in the first quadrant gives me the same tangent value as 6 pi over 7. Well, here's 6 pi over 7, and I know if I move over here, I know that I'm, first of all, pi over 7 degrees away from this quadrant and this x-axis, so I know that here I'm pi over 7 degrees away from that quadrant. So basically what I want to give is I want to give this angle as my solution, because I know by symmetry that these are going to have the same negative tangent values. So this is going to be a negative pi over 7 as my solution. So not quite as basic as the previous problem, but you use symmetry to put you back into that fourth quadrant, which gives you a negative pi over, between negative pi over 2 and pi over 2 solution. Let's do it again. This time we'll use the cosine. 7 pi over 5. I have no idea where that is, but I know my cosine value has to be answered between 0 and pi. And if I was to find 7 pi over 5, that's not going to be between 0 and pi. It's somewhere down here. And this angle relative to the horizontal is 2 pi over 5. So I know if I'm going to name a cosine angle between 0 and pi over 2 that has the same x value as this angle here, I know that would have to be in the second quadrant somewhere. And if I'm 2 pi over 5 away from that axis, then my actual degree measure from the origin between 0 and pi is 3 pi over 5. So in this case, my angle measure that I need to give as an answer, instead of 7 pi over 5 or 2 pi over 5, is 3 pi over 5, because that's measured from standard position. Lastly, if I want to find the inverse sine of 3, now this problem is expressed differently. You'll notice every other problem we've done up to this point has had the function of an angle followed by an inverse. This has an inverse followed by the function. Well, if I want to find the inverse of 3, I've got a problem. And let me tell you why. Because sine looks something like this. And sine usually goes from -1 to 1. So it's saying what y value on my unit circle is 3. Well, there isn't one. So this whole statement right here gives me a no solution. Because I can't find a sine value anywhere outside of 1 and -1, since that's the range of sine. So these next problems will require a calculator. One of the things you need to make sure on the calculator is you got it set in the right mode. Our book's going to ask for answers typically in radians. So if you hit your mode button, you should make sure you're in radian mode, which I am. I'll quit that. And then it's just a case of typing it in as you see it. So we take the inverse cosine, second cosine, 0.74, get a value of 0.737-ish. And then we go, and in this case, we're going to take the inverse tangent of -8.27. And I better get a negative answer out of this because it should be somewhere in the fourth quadrant, which is a negative radian measure. So when I hit enter, you'll notice I get a negative 1.4. Now, in this case, you'll notice we're taking the inverse tangent of a negative number, and we just got done saying, well, for sine, that would be undefined. But if we look at tangent, all right, we know tangent has an undefined range. So we can always find what angle gives us a very large tangent.